Look up at the night sky, and the moon appears serene. In reality, it is plummeting toward the ground right now. To understand why it never hits the ground, imagine throwing a baseball. It arcs through the air and lands a few meters away. But if you throw that ball fast enough, the curve of its fall matches the curve of the Earth itself. It keeps falling, but the ground drops away underneath it. Out in space, where there is no air resistance to slow things down, the moon is doing exactly this. It moves sideways at 3,600 kilometers per hour, completing a perfectly stable loop, an orbit, around our planet every 27 days. Suppose a magical spell suddenly robbed the moon of that sideways momentum. Without that extreme speed holding it up, the moon's path would decay into an inward spiral, putting it on a one-year collision course with Earth. Altering a celestial orbit requires massive energy. Our apocalypse follows a slow, agonizing tightening of an invisible gravitational tether. Even from 384,000 kilometers away, the moon pulls on our planet. This gravitational tug creates a slight bulge in our oceans, giving coastal shores gentle half-meter tides twice a day. Within 4 weeks, the moon covers half the distance to Earth. Because gravity strengthens as distance decreases, the lunar pull magnifies, swelling high tides to 4 meters. Every 12 hours, ocean waves rush into coastal cities, stranding buses and overwhelming seawalls. By the end of month 2, the moon has crossed 2/3 of the distance. Tides now rise above 10 meters. Up to 1 billion people living near the coasts are forced to flee inland as salt water permanently reclaims their homes. A hidden casualty is global communication. About 95% of the internet is carried by thick physical cables running along the ocean floor. The cables themselves survive underwater, but the terrestrial terminals connecting them to our cities are entirely flooded, severing data routing across continents. Human civilization is engineered around the assumption that the oceans stay put. As the lunar gravity strengthens, our shipping ports, oil refineries, and data centers become the first victims of the falling moon. High above the atmosphere, the growing gravitational interference reaches our human-made objects. By month 3, communication and navigation satellites find their orbits severely warped. Unable to correct their trajectories as they burn through their remaining fuel, these satellites spin out of control and fail. By month 5, the oceans experience extreme whiplash. At low tide, the water recedes hundreds of kilometers, leaving wide continental shelves exposed like vast deserts. A few hours later, that same ocean water returns as a 100-meter-tall wall, drowning absolutely everything in its path. The oceans are only about 3 kilometers deep on average. They can only absorb so much of this gravitational squeezing. Now, the Earth's solid crust is forced to bear the load, creating tides of rock. Millions of tons of solid stone are physically stretched and compressed. This immense friction destabilizes tectonic plates and ruptures subterranean magma reservoirs. Severe earthquakes tear across the continents, and massive volcanic calderas blast open, choking the sky with ash. We usually think of gravity as a force that moves water, but when amplified by extreme proximity, it possesses enough raw strength to literally knead a solid planet until the crust shatters from the inside out. Half a year into its fall, the moon enters geostationary orbit. It circles the planet at the exact same speed that Earth rotates. To anyone looking up, the moon appears massive and completely frozen in one spot in the sky, rapidly cycling from new to full every single day. Earth is much more massive than the moon, and its gravity fights back. The pull on the moon's near side is now significantly stronger than the pull on its far side. This differential force physically stretches the lunar sphere, warping it into a giant rocky egg. Down on the surface, the atmosphere is saturated with the fallout of 1,000 ruptured volcanoes. Dense aerosols reflect sunlight back into space, turning whatever daylight remains into a dim, rust-red haze. Without solar radiation reaching the ground, temperatures plummet. Acid rain and midsummer snowstorms blanket the continents, freezing out the hardiest surviving plants and driving the last remnants of human civilization to extinction. The two celestial bodies are locked in a mutual gravitational teardown. Earth dismantles the moon's physical structure,
while the moon's approach strips Earth of its capacity to support life. By the end of the year, the egg-shaped moon is a mere 10,000 kilometers away. It fills the sky, looming directly overhead and poised for a physical collision. But then, it crosses an invisible mathematical boundary, known as the Roche limit. This is the precise distance where Earth's gravitational pull overpowers the internal gravity holding the moon's rock and iron together. The lunar surface cracks open. Millions of tons of rock shear away. Instead of striking the ground, the entire moon simply shatters, breaking apart into countless separate fragments in the vacuum of space. Instantly, the squeezing of our planet stops. The oceans drain off the continents one last time. High above, those millions of lunar fragments smear out along their orbits, catching the sunlight to form a shimmering ring system. Earth's superior mass prevents the physical impact. Our closest celestial neighbor settles into a shimmering ring of dust and stone, visible from every corner of the world. We survived the fall, but it leaves behind a totally different sky.
Which brings us to our curious question for today. If humanity had evolved under a sky filled with spectacular Saturn-like rings instead of a single moon, how do you think that would have changed our mythology and our relationship with the stars? Let us know your thoughts in the comments. Thanks for exploring the universe with us. If you want to keep feeding your curiosity, click the videos on screen to watch our next experiment.